So the custodians are doing everything they can, but like, there's just not enough time to vacuum every day. But luckily, we do have enough secretaries. So our secretary hooked me up with a new pencil sharpener. So if you've used that recently, you probably got annoyed by it. It is new, but let's be nice to it. With any pencil sharpener, pushing it in harder is not the solution. If the blades are getting dull, pushing it in harder is not going to help. So today, 232 is homework. Tomorrow we will work on the closure, but guys, I'll be honest, I doubt we get done with 232 today. So don't worry if we don't. So we'll finish 232 tomorrow, and then I'll give you some class time to work on the closure. I have the closure that I can give you today if people want to start working on it because you've already maybe done the 232 homework. And Friday will be a Chapter 2 Mastery. Yo, look at me for a second. This chapter has been 3 sections. The final section we're on right now deals with graph scaling. I plan to only have like 1 question about that on the test. Most of the test will be 2.1 and 2.2. Okay, so graph scaling. We'll still do axis scaling like we've been practicing, but the whole put all the points on the graph and make the best decisions and stuff, I'm not going to expect you to master that in 2 days, right? We just started working on that like yesterday. So axis scaling, still important. For the stuff we're going to do today of trying to make like the best graph possible, I don't want you stressing out about that. We need to learn it, but I'm not expecting you to master it by Friday. Cool? I got realistic expectations here, right? Because we're all just humans. We can only do the best we can. All right, so your homework had the multiplying mixed numbers at the top. I wrote a bad word on my paper. And our reminder, if we need it as we come down to these problems, and I wrote a new post-it note using the word segments because I realized that's probably better. So to scale an axis, we do distance divided by segments. I should really probably put this like in a box so it doesn't look like multiple divisions. So our answers here for the first axis, you should be scaling by 8s. So your numbers that you wrote down should have been 32, 40, 48, 56, 64, 72, and that gets you all the way up to the end of the axis. If you didn't write down all the numbers, it's okay. Throw the extra ones on there if you want. B, we sort of did together yesterday, going from 0 to 1 and then past it. Lucas?
Is it alright if I did? I'm going to guess just fine, but I did 1, 4, 2, 4, 3, 4.
Yeah, the fraction form, absolutely fine. You know.
I was going to guess like, oh, it's the same.
I kind of like fractions better. It is the same, but I kind of like fractions better. People that are really focused on money like decimals, because that's like money is always in decimal form, really. But either way, fractions or decimals. In C, we had 2 different axes. They do not have to scale the same. So guys, I want to show you my paper again, but I got to move this post-it. There is a misconception, like people think something that is not true, that X and Y axes have to scale the same. Absolutely not necessary. So here on part C, you should have 3, 6, 9 on your x-axis, but then here, this is only a half, because it's between 0 and... Guys, this is always 0 down here, right? It's 0 for the x, 0 for the y. And then up here would be our 1.5, because if each gap is a half. Same thing over here with this axis. We have 1, 2, 3, 4, 5 gaps, making each of these worth 4. So 4, 8, 12, 16 gets us to 20. And then here, what was each of these worth? 4. So we did 4, 8, 12. For the magic diamond problems, any questions on those? The top is the product. Bottom is the sum. Guys, like I've been saying since August, I know you can copy answers down with how I structure all this. If you don't know how to get an answer, you owe it to yourself to ask a question. So as we get to the back of the paper then, I already had somebody ask me about 117, so thank you very much to that person. So 117, when we go to add or subtract fractions, we're back to that more difficult work. right? Because we said multiplying fractions is kind of easy. Sorry, don't tell your parents. Sorry. So hold up. This doesn't have to be super difficult. It's a little bit more difficult. But guys, just like we broke up numbers for multiplication, look up here. I'm going to break these two numbers in A and work separately with the whole number pieces and the fraction pieces. So 7 plus 2 is 9. And then I have 5/8 and 9/16. I know to add or subtract fractions, I gotta have common denominators. So 5/8, I multiply by 2 on top, multiply by 2 on bottom, and we get 10/16. I want to put an addition here because we know we already have 9 and we're going to have these fraction pieces. So I have that 10/16 from my first fraction, and I still have 9/16. And I got common denominator, so that's nice. I'm still going to write my 9 separately. What is 10/16 plus 9/16? 19/16, which picks me up an extra whole, right? Because this is really going to be a mixed number. So this is going to turn into 10, and how many do I have left over? 3/16. We could do the same thing with B, so I'm not going to do it for you. Our common denominator would just need to be 24, right, between 8 and 6, I think. Yeah, you could do 48 if you wanted to. Now, guys, the subtraction piece. Look at C with me. I'm again going to break it up. I should have eyes up on the board because you probably didn't do it this way. I need to subtract 6 and 2/5 from 8. Could I start by just doing 8 minus 6? Yep, what's 8 minus 6? 2. And now I still need to take away that 2/5 because I didn't do it yet. So either, I can just go ahead and try to work in fifths, or 2, if I think about what is 2 in fifths, if I want to get common denominators, I can just make a denominator of 1, and then what would I need to multiply this fraction by? 5/5, right? So 5 on top, 5 on bottom. That becomes 10/5 minus the 2/5. 8/5, which you could just leave your answer like that. Or 1 3/5. So there's A and C for you. On 118, 19, 20. Here's your answers. If anyone wants to go over one, we can. But I'd really just like you checking answers. Remember, the median is the middle number. The mean is when we add them all up, divide by how many you have. Lucas?
We go to D to the diamond.
Oh, back on the front? Absolutely.
That's what I didn't get it.
Good morning, Shinsu Rodriguez. Please come to the Phoenix office. Shinsu Rodriguez, please come to the Phoenix
They
office.
just don't pronounce everyone's name correctly.
They don't.
It's okay. They don't know you guys as well as we get to, because they only see you for brief little minutes. So 31 is the what? The sum. And 234 is the multiplication, the product. I have two options here. I can either... Sorry, I was confused because it sounded like somebody was talking over me. I can either start listing things that could make the sum, or I could start listing things that could make the product. So if I think about my sum of 31, 30 plus 1, right? That would work. But does it multiply to get 234? No. So maybe I'll jump to one of the more middle. So 15, and what would need to add with 15? 16. And guys, I do not expect you to do these without a calculator. It's cool if you can. But then I can test, okay, what's 15 times 16? Okay, I'm close. So what about if I made it like 14 and 17, right? Or 13 and 18. Every time I go down one here, I go up one here. Or 12 and 19. And then I can just test all of these. 12 times 19, since somebody shouted that out. 13 times 18. Hey! Got it! Guys, this is what we're practicing here, is playing with numbers. Because our goal is to just get you more comfortable thinking through what numbers do what. I don't expect you to know this. I don't know this. Like, when I look at this diamond, come on. If you think I look at that, I'm like, oh, 13, 18. You're crazy. No, like, no one does that. I mean, there are, like, very few people who are, like, savants. Damien is one of those custodians who's doing everything. If you see him, thank him. He's amazing. So, I just make a list of options. The other thing we could do is do 234 divided by whatever you want to try. And then you have what else it would multiply by. And you check, well, do those things add up to what I want them to? So here, if we did it with 13, it gives us that other number of 18. So our numbers here end up being 13 and 18. Questions on that? We just kind of list out options and see what finally works for both of them. Oh, I think I got really busy and excited yesterday. Did I tell you that this isn't broken? I'm fine. I just got 2 weeks in my splint, whatever you call this thing, brace. Any questions on the probability in 118? Be careful with questions that are not do something. Like B there is what's the probability she will not draw a club. So it's everything else. There are 13 cards of each suit. There are 13 cards of each suit. Yep. So guys, if you need to look up information about a card deck or come talk to me about information about a card deck, you're always more than welcome to do that. Any questions in 120 converting those numbers, either verbal, decimal, percent, or fraction, into the other forms? You don't often see numbers like 9/10 written out as the word 9 and the word tenths, but that's a good practice, or a good strategy to practice. Go ahead, Vanessa. All right, moving on. So, I gotta admit something. No, I was not lying. Trust me, I try to tell you in the moment if I need to lie to you. I just tell you right then and there. Because sometimes I need to lie, but I can tell you I'm lying. So, yesterday, this is our paper from yesterday. I guided you to make these choices, and I don't think this was a good choice. I don't think switching length and wingspan worked out very well. So true confession, in the afternoon, we looked at this and we said, meh, this doesn't look any better. So the afternoon class kind of threw a little shade at you guys, but it was my fault. So, like, they threw shade at me, really. But, so we, the afternoon class, did this, except without the red bubble here, because I left them feeling okay about what they did. But quite frankly, I think you guys, I think we can do better than this. So the afternoon class, what they did was they kept length on bottom. And I told them we want to use as much of the graph as possible, because when we ended up with a graph like this, it felt really silly. Right? Like, this doesn't use very much of the graph. It feels like kind of nonsensical. But likewise, this graph doesn't use the whole top part. So, what I want you to write down somewhere is that just like what we've been writing down, but now for axis scaling, we want to do distance divided by number of boxes. Now, if you see my little note there, sorry, I actually have this, I took a picture of this for you guys, just to make it a little easier. My little note there of what we have available of boxes available. But what we're working with on this resource page, we only have a certain number of boxes available. So go ahead and look at the bottom left of your resource page, right? There should be an open graph there that we haven't used yet. Let's steal the strategy from the afternoon class. I like the scaling we did with the length because these points, they use up most of the graph. What scale did they choose for their x-axis? Well, let's do the math, right? Our x-axis, if we keep it as the length, what's our biggest number in the x-axis? 5. So 5 is the distance we want to go. Count how many boxes are down here on your paper. Like, don't try to count it up here. That'll be really hard. On your paper, count how many boxes we have down here. Yeah, a little over 20.
No, 21. It's 21 exactly.
So I think it's either 21 or 22 potentially, but yeah, like so 20 seems like a nicer number than 21. So guys, our distance, you might want to jot this down in your paper somewhere. Our distance was 5. We divide by 20, and we get 1/4. That's the scale we used. Every box was a 4. So the other way we can say that is every 4 boxes makes 1. So another 4 boxes makes our 2. Another 4 boxes makes our 3. Go ahead and do that with your x-axis and make sure you label it length. On the resource page I gave you. Did you lose the resource page? I've got extras. That's the homework. That we might need to talk. For now, you can skip it, but this is not the paper we're on right now. This is the homework. I'm thinking we can do better. Monty, you might need to work with somebody if you don't have that paper. I don't think I have any extras. I gave them all away. All right, so for our Y, what did we label Y originally yesterday? Well, the other thing we have. So wingspan. So let's label this wingspan. Wingspan. What is our biggest number in wingspan? 14. So the math we want to do to scale. Ooh, I forgot that I put this up here. Now you're gonna this should look like 1 here, 2, 3, 4, 5. So guys, they just went by ones. They did 1, 2, 3, 4, 5, 6. Like every box was 1, but they didn't use it all up. If we do 14 divided by 20, that takes us to like here, I think. What number would be nicer than 20 with 14? 21. Because 7 goes into both of them. Right? So guys, think about how we can make things work out nicer. Right? I'm trying to like teach us how to make math a little bit easier. This tells us 2/3. Now, wait. We want every box to be 2/3. There's a different way to say this. 2 distance, right? We had distance on top, every 3 boxes. So what we're gonna do is count 3 boxes and then put a 2 there. Count 3 more boxes, and what will go there? A 4. Count 3 more boxes, and 14 lands right at the top of our graph. We're going to be better than 3B. Now, plot your points on your graph. So, like 5, 14. 5, all the way up. 5, 14 will be way up there. You can use either of these. It doesn't matter. Yeah, you can use either of those graphs. So we're putting the points up there on this graph. So the first one is 514. So we go all the way up to 514. So guys, this is not on your paper. It's only up on the screen. Perfect. Yeah, that's awesome. Thank you. By the way, we got a couple lost things up here, just if you're missing a pencil sharpener or something. 2.35 doesn't have to be perfect, but it's above 2.25, so we know that. Yeah, the general area.
Somewhere in a four box radius, we'll be fine. 2.35.
So guys, this is a slightly weird scaling, but like when we go to place our 11, like our y of 11, you know that if it's 3 boxes in between, we'll be right in between the 10 and the 12, which is right in between the boxes. That erased too much. So my point, I'm a little bit too far up. Be right in between the lines. And then 310. Yeah, but sometimes that just happens because, like, that's just, we don't have any points there. The most important thing is that we use, like, the extent of our axes. So you're right, there is still a part of the graph that doesn't get used. We were about to use it. So, if you had a bat that was 0 inches long, how big do you think its wingspan would be?
0.
Probably 0. So we could guess that there would also be a bat down here. And then, like we had tried yesterday, but our line went really steep and right up off the graph, let's try to do a line of best fit. But let's use the origin, because it makes sense that a bat that is 0 size would be 0 size, right? So, line of best fit, we said grab a ruler. Oh, by the way, if you don't have a ruler in your binder, you kind of should, but there are rulers over there, and there are rulers up here. So when you need to use rulers, if you don't have one, borrow one from over there or up here. Trying to keep things a little bit more spread out. Uh-oh. I don't know if I can grab my line now. Would that be a line of best fit? Why is it not the best? Who can tell me? Farah? It's missing all the other dots. Okay. Down here. Nah, now it's not hitting any of them. So something probably maybe like that. That's pretty good. I think the red dot is kind of what we call an outlier. It doesn't match everything else. So if I try to operate using the red dot, it kind of messes up my other points. So we try to go where most of the data is. Now our green dot could also kind of be a fluke, but it's closer to the line. So just get your line somewhere as close to through as many of the points as you can. Ooh, I like that idea. Use a highlighter for line of best fit. That's a good idea. All right, so now I want to leave my screen on this screen. So I don't want to flip to the next slide. But the next problem that we need to talk about, like you guys as a team, Peyton is now trying to predict, because she doesn't have the data, the wingspan of a common fruit bat, which is what we have here in Ohio most of the time. It's just bats that even if they bite you, it wouldn't be a big thing. Like any animal, if an animal bites you, you should probably go to the doctor and make sure everything's fine. But like, it's not like a poisonous bat. You're not gonna like turn into a vampire or anything like that. So fruit bats are fine. They eat mosquitoes, and a fruit bat is 2.75 inches long. So its length, which I forgot to label down here, its length, they tell us, is 2.75 inches. Talk with your team about how we can predict that bat's wingspan. So the fruit bat is 2.75 inches. What if you didn't have a table? What if you only had the graph? Let me make that. Can you use the table to make this prediction? Hey, I need to change my question. Can you use the graph and ignore the table? So I got people trying to just use the table. We just put all this work into making a graph. We should be able to use the graph to help us make this prediction. No, just like right, we're using this graph. So like a length of 2.75, it's on here, right? Could we guess what the wingspan will be? Why do you guess that? Isn't this wingspan? Wait, why are we adding two? Well, that was to get to wingspan. Right? But now that we have a graph, we can do all that complicated math. Guys, I'm scared. I think some of us are working too hard. I'm here to make your life easier. And yes, I might need to pause us. We put a bunch of work into making this graph. And quite frankly, I think it's beautiful. Because we can use it to not think. Yeah. We can use this graph so we don't have to think. Give me your eyes up here. If the fruit bat's body length is 2.75 inches, we can find that on our graph right here. But of course, that's not where the point would be. That's just where the length is. So follow 2.75 up to your graph. And where it hits the line that we just drew, trace that over. And that lets us predict. That's it. That's all we have to do. We don't have to think at all. You literally just find it, follow it, follow it. So try that strategy. If the bat was 1 inch long, little baby bat, the bat was 1 inch long, what do you think its wingspan would be? See, this is when like adding two and like whatever we were doing yesterday wouldn't quite work. What if that was 0 inches long and you still do that two? Like this bat that doesn't exist has a wingspan. Like wait. So one of the ideas that we had yesterday. So the people that are saying what? One of the ideas we had yesterday that Lucas told us was add 2 and then double. And that was great, it worked, but the problem is that doesn't make sense now. Because if our wingspan was 0 and you add 2, or sorry, if our length was 0, you add 2 and you double, we get a wingspan of 4. So a bat that doesn't exist has a wingspan of 4. Like, this doesn't make sense now. So that's why we're using our graph instead of some rule that like worked kind of. This is our data, right? This is data. There's no kind of about this. It's exact. Our line is a model that we created to say, well, this is what should happen. So if our bat was 1 inch long, little baby bat, and I follow this over, approximately what would its wingspan be? Like 3, like just over 3 inches probably. If it was, well, we already have the data up here for like 4 inch and 5 inch. A 2 inch long bat would have a wingspan of approximately 6. Is this making sense how we can use the graph? Yeah? So now, our classmate is all excited about this ability. So I need you to take a piece of graph paper. Probably today it doesn't matter if it's the bottom half, but I need you to have half of a sheet of graph paper available. So I folded mine in half and used the top half. I don't care if you use the bottom half, but I need you to have half a sheet of graph paper available to use. Right? Fold it hamburger style if you want. I folded mine. The title of today is Scaling Graphs. 232 Scaling Graphs. I'll write it up here again. So, now that we're on graph paper, one thing that you want to remember is if there's space, I've got this little yellow note up there, a post-it that I put on my paper. If there's space, we can extend our axis, right? So there's no rule that your x-axis can only have 10 boxes. Like, there's no rule at all like that. You can do whatever you want. But what we want to try to do is however many boxes we use up the whole graph. Right? Make our axes appropriate, like put the numbers on them appropriately so we go all the way out to the end, all the way up to the top. So our buddy, Andre, our buddy Andre is working in his family's juice shop. They've got a Math Berry Madness smoothie. You would totally order the Math Berry smoothie, right? So they've been tracking data. We're going to go ahead and say that the day is our X value and the smoothie sold is our Y value. I want you and your team to decide how many boxes do you want to use on the X-axis and how do you want to scale them? How many boxes do you want to use on the Y-axis and how do you want to scale them? Because I doubt you actually want to use 38 boxes. And at least on my paper, I can't fit 38 because I already drew this here. I don't have 38 because smoothies is going to be Y, right? So we're going to have to scale the Y-axis. The X-axis only goes to 12. You might be able to get away with not really scaling that. Give it a shot. I'll give you a couple minutes. Then we'll come back together and we will do this to finish class. Yeah, go ahead and label your axes, days, and smoothies if you would. Days is our X, smoothies is our Y. Days is our X, smoothies is our Y. Anyone want to give us a suggestion for our X-axis? Should we like go by 2s, go by 3s, just go by 1s, go by like a half, go like Lucas?
Basically a box a day, but I put it by twos. So every 2 boxes, that would be.
You know, I love that. So, hey, listen to what Lucas said, because if you weren't listening, he said he did every box is worth 1, but he only labeled it every 2. So 2 boxes is worth 2. So every box is a 1, but we don't need all of those numbers. Whoops. And I'm running into a situation of I need to extend my axis, but this arrow says it's allowed to be extended. It's fine. So if I had a pencil, I would erase that and just extend my axis. So then 10 and 12, and that's far enough now. Go ahead and make sure that your x-axis is scaled in a way that you think is nice. And then smoothies, you probably haven't made a choice there. What number would be nicer to work with than 38? Could we like round that to something that would be nicer to do math with? Yeah, like 40, right? I would totally do 40. Sometimes we do a squiggly equals for like approximately or rounded, or like we're just going to take some liberties here. So if you want to use 40, would 40 divide by 10 boxes all right? Yeah. If I use 10 boxes vertically, I already got that many on my paper. If I divided 40 by 40 by 10 boxes, each box would be 4. Right, so 40 is how far I want to go. I don't really have to get to 40. But if I do 40 divided by 10 boxes, I can make every box worth 4. Sure. Now, do I need to label every box being 4? No, like Lucas said, I could skip, and if I jump to the second box, that's going to be 8. 16. Sometimes we put the numbers in between kind of smaller. And then start graphing these points, because this is where we're going to pick it up tomorrow. So like our first point at 3, 3. Okay, 2, 3 would be right here. I'm probably right about there. Our next point, 4, 5. So probably just above that first box in the Y. 6, 10 would be our next one. So right between 8 and 12. Right, so right between 8 and 12. Go ahead and try to graph those last few points. And then we'll head out of here in about 1 minute. All right, guys, I do have to cut us off because we are out of time. So we will come back to this problem to start our lesson tomorrow. And then we actually have a problem in the textbook about the Columbus Recreation Center. Like what some of you have probably been to. Because the Columbus Rec Center is sweet. So, all right, have a wonderful day, guys. Please try to do your homework. And please come ask me questions. It's my favorite part of my day. When I get to do math with you guys, like one-on-one. Did I eat pizza yesterday? No, I ate a burger. My mother-in-law took us out, and I had a burger. So no pizza. But I did divide my burger in half, and I have half of it left over for today. Food is always a math problem. Now, math problems aren't always food, but they're better when they are.